So, hello and good evening, everyone. Can I get a confirmation in the chat box whether I am clearly audible or not? Okay, so am I clearly audible? Yes or no in the chat box? A plus one will. Okay, thank you. Thank you, Sumit. Okay, so this is the special GFG Weekly Coding Contest, the 100th one, right? So, were you guys able to solve all the questions? How many questions were you able to solve? Can I get a count in the chat box from each and everyone? How many of were you able to solve each and every question of this weekly coding contest? Okay, so someone is saying 3, someone is saying 1 0. Okay, Yogesh is saying 2. Okay, so I can take an average that everyone was at least able to solve 1 or 2 questions, right? So don't worry, we'll be analyzing each and every question and we'll be discussing the solution and we'll be understanding how we can actually reach down the solution for this question. Okay, so let me share my screen. I hope my screen is visible to everyone. Okay. So first of all, we'll be reading down the problem statement. And before moving on to the explanation part, let me give you a small introduction about myself. So my name is Jay Dalsaniya and I work as a DSA mentor at GeeksforGeeks. And you guys might be seeing me for the first time in this weekly coding contest, but already been taking out the editorials for POTD. So if you are practicing POTD, then do attend my session and you'll be enjoying it a lot. Okay, so I'll be going through basic and I'll be explaining each and everything in a proper manner. Okay, so let's start. And during the session, if you face any kind of difficulty, just mention it down in the chat box. So I'll be simultaneously looking at the chat box as well. Leaderboard. Okay, so you'll be getting the leaderboard also. Okay, so let's start with the first question, that is Geeky9 log. I see someone already wrote that the first question he was able to solve only after like many attempts, right? But let's see. Your explanation will be next level. Okay, thank you. Let's hope I'll be giving you the best output. Okay, so let's first of all quickly go through the problem statement. The problem statement over here seems to be very complex, but it's very simple and straightforward. So what you have to do, basically, if I summarize the entire problem statement after reading it down, I'll be summarizing it. So Geekina gave Geek a number n. So what you have to do, find a positive integer a that lies in the range 0 till 10 to the power 9. Okay, so only the inclusive range will be 10 to the power 9, not 0. And similarly, such kind of number b needs to be found that satisfy the equation log of a base 2 plus log of b base 3 will be equivalent to the input number n. If it does not exist, then you have to report it does not exist. Okay, basically, you have to write down the logic in a function and that function will be returning an integer array. So if the answer is possible, that integer array will be containing two integers a and b. If it is not possible, then return an integer array of only minus one. A single element in the integer array needs to be written down. Okay, and there is a something given as well, that the precision should be equivalent to 6 decimal digits. Okay, so the difference of the number which you are getting log of a plus log of b and the actual input number, the precision should be up to 6 decimal digits. Okay, if your number which you have written a and b lies in this precision, then only then a statement will be printed accepted. If it is not possible and you written -1, no such a and b exist will be the statement that will be printed. And if your answer is wrong, then rejected will be printed on the output screen. I hope you were able to understand the basic. Was it me only who did terrible in this contest? Okay, don't worry. Like the contests are just to upskill yourself, right? So the more contests you participate in, you will be gaining much knowledge and much experience, right? And you will be doing your best at the final time. Okay, yeah, I'll be explaining. I was just reading down the problem statement. So now let's understand with the help of okay, why I'm not able to see this part. Just a minute, I'll be sharing my screen. Okay, I've shared my screen. When will be the leaderboard will be published? Okay, it will be published in short duration. Don't worry. So I hope my screen is visible. So basically, if I summarize the question, you have to find out two integers a and b that lies in the range 0 till 10 to the power 9, where 0 cannot be that a or b, and this a and b which you have found should satisfy the condition that log of a base 2 plus log of b base 3 should be equivalent to n, where n will be your input number, and the precision of the integer which you are returning should be equivalent to 6 decimal digit. That means the difference between this and the input number should be equivalent to 6 decimal digit. Okay, it cannot be greater than 6 decimal digit. That means the absolute difference between n minus log of a base 2 and log of b base 3 should be lesser than 10 to the power minus 6. Okay, this means the difference of the decimal. Okay, so in the input test case number 1, you are given the value of n is equal to 3. For n is equal to 3, the output comes out to be accepted. So what should we return? Okay, the output comes out to be accepted, and the number which we need to find a and b. So let's see, for n is equal to 3, can we get to a and b or not? Okay, so log of a base 2 plus log of b base 3 is equal to 3. So over here, you might be aware that if the power of the number and this part, let's say if I take the value of a equivalent to 2, so that 2 can be written as 2 to the power 1. And similarly, over here, if I take 9 instead of b, so b can be written as 3 to the power 2, right? And this will be giving you what? This can be reduced down to 1, this can be reduced down to 2. You can take this base, this power in the front, and log 3 base 3 will be 1. Similarly over here, so 2 plus 1 will be equivalent to 3. So over here, the array which you are returning should return 2 and 9. The content of the array should be 2 and 9, and in that case, the output for n is equal to 3 will be equivalent to accepted. Was the question understanding clear to everyone? A quick confirmation in the chat box. Okay, by the help of this question, I'll be explaining you logarithm in a different way. Okay, so I can like guarantee you that after this explanation part about logarithm, you will never like you will start seeing the logarithm in a different way. Okay, not getting the log part. Okay, so let me give you an idea. If you are saying that let's say log of a to the power b, and over here in the base the same value is given to you, then you can take the, this is the basic logarithmic property, that log of a base a will be equivalent to 1, and whatever is the power, you can take that power in the front. Okay, I hope you are able. Log of a base a will be equivalent to 1, hence b into 1 will be equivalent to b. So this is what I have written. The actual value which were passed was 2 and 9 for a and b. Okay, was it clear? Okay, so how we can find the value of a and b? First of all, we need to understand that over here you are given a very big range starting from 1 till 10 to the power 9. So you might be wondering that let's try out all the combinations of a and b and just write down a solution where you will be getting the sum of log of a and b equivalent to n. But I cannot use nested loop to try out all the combination, because at max the loop will run 10 into 9. The outer full for loop will run 10 to the power 9 times, and the inner will also run 10 to the power 9 times. This will be equivalent to 10 to the power 18, and it is not acceptable according to the time complexity, according to the time limit. Okay, so we cannot try out all the combinations. So can we reduce down the search area? First of all, we need to understand, do we really need to iterate over 10 to the power 9 and 10 to the power 9? Okay, so what was your approach? I would like to know from the audience, how did you reach down a solution if you were able to solve this question? So what can I do? Can I know from the audience, what was your approach in order to reduce down this range 10 to the power 9? The solution is pretty easy. We simply need to try out different combinations of A and B, and then just take the A and B, which is giving you the sum of log equivalent to n. Okay, but the range is very huge, so I need to reduce down the range. Okay, binary search. Okay, so we can try out binary search, but then at least, let's say 10 to the power 9 iterations in worst case will be possible, right? Half of the numbers. So binary search, I don't think we need really binary search. We can at least, you can reduce down this range to such a small number that the overall time complexity of the solution will be equivalent to order of 1. Let's see. Yes, just current and log 10 to the power 9 base 2 is max 30 and log 9 base. Okay, yes, exactly. So we can move in the direction yes, you are exactly correct, just current and through. Exactly. I consider combination of power of A and B. Okay, so basically, first of all, we need to understand how we can figure out how we can reduce our search area. So let's say you might be aware that 2 to the power 4 will be equivalent to 16. So you can write down the power in terms of logarithm and base as well. So log of, pay proper attention over here, I'm changing this power equation into logarithmic. So to log 16 base 2 will be equivalent to 4. You can call this as argument. You can call this as power. 4 is the power and 2 is the base. Okay, so you can observe log of argument base will be equivalent to the power. So you have reduced down the argument into a smaller term, that is power of 2. So over here, what can be the highest possible value of this log 10 to the power 9? So log 10 to the power 9 base, it will be equivalent to something like 29 point. Let's find out what will be that answer. Log 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so this value will be equivalent to something called as 29.89. Okay, so basically the maximum value of 10 to the power 9 can be equivalent to, that is log of a base 2 can have maximum value equivalent to 29. At max it can be equivalent to 29. So if you are able to figure out this range, from this you can find out that what is the actual argument. Okay, so if you are already known, if you already know this value 29, then from that you can actually figure out what is the argument by just converting, just taking a look at this observation. This observation is very important. From this observation we can convert the argument to the power of 2 and to the power of 3. Okay, so log a base 2, that is log 10 to the power 9 base 2 will be at max equivalent to 29, the integer part. Okay, I'm only saying the integer part. Similarly, for log 10 to the power 3 base 10 to the power 9 base 3 will be equivalent to, let's say it will be something around 18. Okay, at max it will be 18.86 something. So let's take the value to be equivalent to 18. Okay, so at max you simply need to iterate over the range. You can at least try out all this combination, right? If you want to find out the value of a, let's say you are figuring to find out the value of a, log a base 2 is equivalent to I and log b base 3 is equivalent to j. So the value of this I can be equivalent to, at max equivalent to 29, and the value of this j at max can be equivalent to 18. So what can be its smallest value? First of all, we need to find the lower bound of it as well. Okay, so how will we get this part? Are you getting my point? Like, was it clear till now? Everyone, yes or no in the chat box? Can I get a quick +1 in the chat box if this part was clear? Okay, thank you, Sai. So we need to find out that what can be the smallest value. In the question, it is given that if you observe what can be the smallest value of n. So smallest value of n possible is equal to 0. So that means log of a base 2 plus log of b base 3 will be equivalent to 0. So both this value needs to be 0, right? So that means you are trying to say log of a base 2 will be equivalent to 0 and log of b base 3 will be equivalent to 0. So what can be the value in this term? A value of a. So this is saying something like that. You are trying to say 2 to the power 0 will be equivalent to a. And the range of a given to you is from 0 till 10 to the power 9 where 0 is not included. If 0 is not included, the minimum value of a given to you will be equivalent to 1. Clear? Similarly over here, the smallest possible value of b will be equivalent to not 0, it will be equivalent to 1. So 3 to the power 0 can be equivalent to 1. You cannot take 2 to the power 0 is equal to 0, is not possible. So a cannot be equivalent to 0, similarly b cannot be equivalent to 0. But their power can be equivalent to 0. So the smaller value on which we can iterate, that would be from 0 till 2 to the power 2 to the power 29, and over here as well 0 till 80. Was this part clear? The smallest power of 2 and 3 which you can find out will be equivalent to 0 for a and b. Clear? Okay. So now we simply need to iterate over this part, and from this we can figure out the value of a and b by simply finding 3 to the power j and 2 to the power I. Okay, if we are iterating over this range in order to find out the value of a is nothing but 2 to the power I and b is nothing but 3 to the power j. If you have paid attention over here at this part, this conversion part, then this will be easier for you to understand. Okay, so we will be iterating over this range 0 till 29. We'll be trying out all the combination in this range 0 till 29 for a and 0 till 18 for b. So we simply need two nested for loop. The outer for loop will be iterating over different powers of 2 and the inner for loop will be iterating over different powers of 3. So the equation can be simply written as I is equal to 0 to I is lesser than 30, right? 0 till 29. This will be power of 2, and over here j will be equivalent to 0 till j is lesser than 19. This is for power of 3. I did not understand why the lower bound is 0. See, what can be the value of a? A can be from 0 till 10 to the power 9 where 0 is not included. Okay, so you are trying to say log of a base 2 will be equivalent to something I. Now, is it possible that if I take the value of a equivalent to 0, then you are trying to say, first of all, this equation can be written as 2 to the power I will be equivalent to a. So I'm trying to say if I take the value of a equivalent to 0, then you are trying to say 2 to the power I will be equivalent to 0. This is not possible. This part is not possible. Hence, in the question it is given that the maximum value, that the minimum value of a can be equivalent to 1 and the maximum can be 10 to the power 9. If the minimum value of a is equal to 1, log of 1 base 2 will be equivalent to I. So that means 2 to the power I will be equivalent to 1, 2 to the power 0 will be equivalent to 1. So the smallest value of I can be equivalent to 0. Similarly for 3 as well. Was it clear, Sai Subhash? We are iterating. Can I get a quick +1 in the chat box so that we can move forward. Okay, I hope. Okay. So now we simply need to iterate over this part. Now, what else do we need to do? I simply can figure it out that what can be the value of a. A is nothing but 2 to the power I, right? So I can just use some power function to find out the value of power 2 to the power I, and b is equal to power 3 to the power j. Okay, and this part can only be done, it is only required to do this part when you find out some value of I and j if the value of I plus j will be equivalent to n. If this is the case, if I plus j is equal to n, then you have to check out whether the difference, the absolute difference, the precision should be equivalent to 6 decimal values, right? The question says that the precision should be equivalent to 6 decimal values. So for being on the safer side, what I'll be doing, I'll be finding out whether the value of I and j which I have found, that means whether the value of a and b which I have found, that difference should not go beyond 6 decimal precision. Okay, so I'll be checking if the absolute difference of n and log of a base 2 plus log of b base 3, this absolute difference is lesser than 10 to the power minus 6, then and only then I'll be returning the value of a and b, that is an array containing a and b, because the question says that the precision should be maintained. Okay, in this case only I'll be returning the value of a and b. If this is not the precision I am getting, then I will search for other numbers if possible, and this is the end of the outer and inner for loop. End of the for loop. Okay, and at the end, if you are not getting any answer, then simply return an array containing a single element minus 1. Okay, and from this as well, you can obviously you can filter out in the beginning itself that the maximum value of n, what can be the maximum value of n, what can be the maximum value of n. So I can be maximum equal to 29 and j can be maximum equivalent to 18. So this will be around 40, it was 16, 17, and it will be around 47. Okay, so the value of n, whatever value you are getting for n, if that value is greater than 47, then you don't have any answer, because you need to find a and b in the given range, in this range only. Okay, if this range was not given, then obviously you can take any uh, a very huge number, and then you can find out log of a base 2 plus log of b base 3, then the answer will always be possible if the range was not given, right? Because obviously you can figure out different numbers that will give you the logarithmic addition equivalent to n. Okay, so due to this range, the question says if the answer is not possible, then return minus 1. So this was the reason why you were supposed to return minus 1. I hope this was clear to everyone. A quick confirmation in the chat box, then we'll be coding this part quickly and getting our solution acceptance. Okay, Sushant. Okay, I'll try. If you are like enjoying my session, then that's really good, thank you. Condition, sir, I plus j is equal to n. Over here, this is the condition. Okay, I plus j is equal to n. See, at the end, the value of this log and I'm iterating over the answer. Okay, I'm iterating over this answer. This is I and j, and here you will be getting the value of n. Okay, so I'm iterating over the logarithmic value. I'm iterating over the logarithmic value. Okay, I'm iterating over the logarithmic a base 2 and logarithmic b base 3. And whenever I get the value equivalent to I and j, so I am passing this value of a and b, that would be 2 to the power I and 3 to the power j. I am passing this value. What about the float? We don't need float value, no, because the integer, the input value is already an integer value. N is an integer value. It is an integer value. So the overall addition of log of a base 2 and log of b base 3 will be equivalent to an integer value only. Because finally, and that's why you are given the part of precision, and that's why I'm checking the precision part over here itself. Okay, because the logarithmic cannot be integer, it will be in let's say the data type of log will be in decimal, double, something like that. So that is the reason you are given the precision part. See, log of a logarithmic values are in decimal only, right? They are decimal values. Hence, decimal plus decimal will never be an integer, but this n is an integer value. This n is an integer value. Hence, in the question itself, you can observe over here, you are given that your solution will be accepted if this precision is up till 10 to the power minus 6, that is 6 decimal of precision is required whenever you are returning value of a and b. Okay, because the addition of logarithmic will be a decimal value. But okay, why? But they can be real close to the precision, right? Yes, yes. There should be precision of this addition and the input integer. Input number is an integer number. Logarithmic addition is a decimal value. So precision up till 10 to the power minus 6 or 6 decimal of precision is required. Okay, so Dev, I am not sure about the leaderboard part, but it will be updated soon enough. So now let's quickly code down this part. Okay, so just I'm coding it the algorithmic part. So as I already mentioned, if the value of n is greater than 47, the answer is not possible, and the reason is clear out. I've already cleared the reason that the range of a and b is from 1 to 10 to the power 9, and for such logarithmic value, the maximum value of log a base 2 can be equivalent to 29, and log of b base 3 at max can be equivalent to 18 for the given range of a and b, and that is why the sum or the input number can never be greater than 47. It will be the answer, the number should be always lesser than or equal to 47. Then and only then the answer is possible. Okay, so I'll be adding that condition. If n value is greater than 47, then do nothing, just without any further delay, just return the array containing a single element, that is -1. Okay, for the rest of the part I'll be iterating. I is lesser than 30 and I plus plus. These are the power of I. This is the power of 2, and let's iterate over the other part. J is lesser than 19, right? The other power of 3 possible was up till power of 3. And now over here I'll be checking if I plus j will be equivalent to n or not. If it is possible, if this part is possible, then first of all I'll be taking out some values, right? I'll be needing some value, that is 2 to the power I and 3 to the power a. I'll be calling it as a and b. A is equal to, let's say, there is a power function in Java, I'll be calling that function, and b is equal to 3 comma 3 comma j. Okay, and let's say this value returned is an integer value, and now 48 can be reached with 10 to the power 9. You also need logarithmic of a plus b as well. Okay, so now over here I need to check the precision part. How are we going to check the precision part? We need to find out logarithmic of a base 2 and logarithmic of b base 3 and take the absolute of n and the sum. So what I'll be doing, the logarithmic will be a double value. Let's say I'll be calling it as a value, and you might be aware about this property. If you are not aware, just pay attention that log of, let's say, uh, log of a base 2 can be written as log of a base n divided by log of 2 base n. Is this part clear? This property is this property clear to everyone? This is basic logarithmic property. Okay. So what I'll be doing, I'll be writing down a function. That function will be called as log, and that I'll be passing a to the power log of a base b. I'll be finding log of a base b and log of b base 3 as well. So let's define that function, and that value will be double because it is logarithmic division. Okay, log of integer a. I'll be calling it as integer a and integer base. So I'll be simply returning log of a divided by log of base. Okay? This is how I can find out log of a base 2, and you'll be able to find a log of b base 3 as well in this manner. Now I need to check the precision. So I'll be having a absolute function in Java n minus value. If this precision is lesser than 10 to the power minus 6, so that can be written as 1e minus 6. Okay. If this is the precision, then I'll be returning a and b, a comma b. Okay, then just simply return the value of a and b. And at the end, if you are not getting any such number, then just simply return an array containing minus 1. Was this part first time I have solved two question? Congratulations, Parmar Piyush, if you were able to solve it. Then if then 3 and 2 if there is no solution for perfect power. If log 3 base 2 and log 2 base 3 is 1, then that will be skipped. How will that be skipped? Log of you are saying log of 3 base 2 and log of 2 base 3. 3 base 2 and log of 2 base 3 will be equivalent to j and it will be equivalent to I. Okay. So this is 2 to the power I will be equivalent to 3 and 3 to the power j will be equivalent to 2. Is it possible? Some power of 2 will be equivalent to this number. 3 to the power anything can never be lesser than 3. 3 to the power 0 can be equivalent to 1, but how can you find out 3 to the power something will be equivalent to 2? It can be point decimal value something. Not possible, right? Guys, what rank? First time I solved two question. Okay, so that's something. So let's compile and run for now. Okay, possibly loss conversion power is let's take the integer value. Because 10 to the power 9 at least can be stored in an integer range, right? So we can do in this manner, and let's try to. Okay, method log in class cannot be applied for this log of a base and double. Acha, sorry, math.log is the function to find the logarithm. Okay, the precision should be up till 6 decimal. Blue game, alpha game. Okay, the precision should be up till 6 decimal. So count if the precision of n and the value which you are getting, this value. Obviously, you are getting precision till it is the difference of the addition and the input number. Input number is an integer value, while the logarithmic addition is a double value because log cannot be integer. So precision is checked over here in this manner that the value which I will be getting and the value of n, which input integer it is, whether the number are close enough or not. Okay, so let's try to submit and see the acceptance. Okay, so we can observe it has been successfully submitted. Okay, so we 10 to the power 1e minus 6 is 10 to the power minus 6. But I think in question given a is lesser than, no, a is over here, you can observe 0 till 10 to the power 9, and b also can be equivalent to 10 to the power 9. Now, was it clear? Can I get a confirmation? Or if you have any doubt, just quickly mention the doubt and I'll be quickly going through your doubts. Okay, a plus one in the chat box so that we can move and solve out the second question. Can I get a plus one in the chat box? Can we subtract int and double? The overall will be you can do the whichever is the powerful data type. Double is the powerful data type, so the overall will be taken as double. Okay, what is the use of log function? Okay, you have inbuilt function that will give you log of a base 2. You need to find out log of a base 3. The base is different from what you are getting. Generally you will be getting the answer for log of something base 10 using the inbuilt function. So if you are saying that log of a base 10, you don't want this part, then you can write down in this manner. If you want to find out log of a base 2, you can find out log of a base 10 divided by log of 2 base 10, and this will be giving you log of a base 2. Okay, you can change the base in this manner. This is basically logarithmic property. Okay, so now we can move towards the next question because we've already taken half an hour. Just quickly give me a plus one in the chat box and we'll be moving towards the next question. So I'll be getting surety that everyone is getting the point. Okay, thank you, Piyush Kumar, thank you, Sushant. Okay, so the next question is help a big pig. Okay, so there is a big pig in Geekland who eats a lot. Okay, however, he wants to get even bigger by eating the food. So one guy from Geekland offered the geek some food in return. He wants Big Pig to help him in his work. Okay, so he'll be offering some food, and in order, like he'll be asking him to do some of the work. Okay, so there is a pig who wants to get fat by eating a lot. So there is a guy from Geekland who will be offering him some work, and in return he'll be providing him food. Okay, so if on the ith day the guy is providing him work, then after eating the food he will be gaining some weight, and after working he'll be losing some amount of weight. So there are two areas, loss and gain, where they denote that gain of I is the unit of weight he'll be gaining on ith day by the food provided by that guy, and loss of I is the weight that he will be losing by working on ith day for that guy. Okay, now since the big pig doesn't know mathematics, he wants you to answer q of his queries, wherein ith query he asks you what is the least amount of days in which he should work for that guy to gain at least query of I units of weight, and return minus one if that's not possible. Okay, so there are few queries given to you by the pig. He says that on ith day, let's say, query of I amount of weight he wants to gain. Okay, so he's saying that I want to gain query of I unit of weight, and for that amount of weight, for how many least amount of days he should work for the guy in the geek land. So you have to find out the count of days, the least count of days for which he should work, so that he will be getting this unit of weight. The first question for input n is equal to 48. In the first question, for input n is equal to 48, a is equal to 10 to the power 9, and b is equal to something is correct answer. Okay. As required for these values and a and b, GFG accepts minus 1 as a valid answer. Okay. Someone says a is equal to 10 to the power. Okay, so there is some problem. Let's check. For a is equal to 10 to the power 9. Let's copy from here only. 3, 4, 5, 6, 7, 8, and 9. And the other value was equivalent to 433 66 8342 8342. Take the subtraction of gain and loss and sort in a decreasing order and then prefix sum. And yes, Paramar, exactly. Okay, so I need to give test cases as well. Okay, Sachin, regarding the leaderboard. Okay, so where is it giving -1? Anil Bera. So you were saying that for n is equal to 48. Okay, okay, sorry, I gave the wrong input format. What's the input format? Just a minute. No such A and B exists. Okay, so you are saying that for some value of A and B, you are getting the answer to be yes. You need to give an. Ten to the power 9. These are the values of A and B. Okay. Yeah, the same thing was telling. Over here, let's take the value of A and B to be static. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And B is equivalent to 4, 3, 3, 6, 6, 8, 3, and 4, 2. GFG testing इंजन की पोजीशन ओपन करो. अच्छा. Okay, Shivam Tanwar. For 48, we were not getting answer, right? So for 48, we can get the answer. Okay, so let's see. So for 48, this A and B will work, and so I'll be finding out the precision. So let's check. Let me print down the value of print again, the value. It's 47.99999. So over here, how many decimal values? 1, 2, 3, 4, 5, 6. See, you can observe over here the value is not that close enough. Okay. If the value would have been, let's say, uh, and let's print the difference of this. Okay, so we'll be able to understand if this value is lesser than 10 to the power minus 6 or not. Okay, so that value comes out to be 9 point something. Obviously, math dot absolute of 48 minus this value. So this value is not lesser than 10 to the power minus 6, right? So it says after this 0.0009. Okay, 9.5 minus 10. Okay, so I think there needs to be, we'll be checking the test case part as well. So if we had any issue in that part, we'll be looking down at that part as well. Okay. Thank you for pointing it out. Yes, yes, I can observe that as well. The value is lesser than 10 to the power minus 6. The problem here is A and B are not power of 2 and 3. See, actually, A and B are not power, but they are the result of power of 2 and 3. Okay. If you observe, you can write down logarithmic in this manner. So, whatever A is given over here, and let's say I is given here, then 2 to the power I can be written as some power, A can be written as some power of 2. Okay. Okay, so now let's move to the next question. I'll be telling the team to check this part as well if we have any kind of problem or not. Okay, so we were reading this question. So let's summarize this question. That let's say you'll be getting a gain array, and this is a gain array, and this is your loss array. That you will be losing some weight on that particular ith day, and there is some query given to you that if the geek wants to gain this amount of weight, then on how many least number of days he should work for that guy in order to gain that much amount of weight. So that would be your query. You have to answer each and every query, and if it is not possible, then you have to return -1. You have to find out list number of days for which the geek should work. Okay, so let's take one of the test case given over here. I'll be taking the example number 2 because the example number 1 is very straightforward. Okay, so for n is equal to 5, and you'll be given the query numbers as well. Query is equal to 3. You are given 6 to 2. Okay, and here is our test case. Let me copy this part. Okay, so we need to answer each and every query, that in order to gain query I number of weight, then how many number of days he should work. So here it is given that guy, let's say this is your entire day. Okay, and on the entire day, in this much of part, you'll be given some work, and you'll be eating in this part. Okay, let's say so at the end, the target of pig is to gain weight, right? The pig is targeting that he should gain some weight, and while working he'll be losing some of his energy, so he'll be losing some of its weight, and after eating he will be gaining some of the weight. This is your ith day, gaining weight. So this is what the question is giving you. So we should only consider, in order to find out the output, it's very logical that we should only consider those days on which at the end of the day you are at least gaining some weight, because at the end you want to gain some weight. That is the target of the pig, right? Please start the question fresh. Okay. Okay, so basically I'm explaining from fresh only. There is a pig who wants to gain some weight, and in order to eat some food, a guy from Geekland, he says that I'll be giving you some work, that you have to do that work on the particular day, and at the end of the day I'll be giving you some food so that you will be gaining some weight. So while eating the food he'll be gaining some weight, and if he is working on that day he will be losing some energy as well, right? So over here he's losing weight while working on the ith day. So this array represents the weight he will gain by eating food on ith day, and loss denotes that while working for the ith day, this much amount of weight he will be losing. So now he wants to answer you this much query, that if he wants to gain 8 kg, then on which particular day he should work. So he's saying that I want to work on least number of days. I want to work for least number of days, but I want to gain at least 8 kg of weight. So you have to figure out that what will be the number of days. So if he is working for that many number of days, at least he will be gaining 8 kg. Similarly, he wants to know what is the least number of days should he work so that he'll be gaining at least 9 kg of weight. Similarly, for 12 kg of for gaining 12 kg, what is the least number of days he should work? So he'll be gaining 12 kgs, at least 12 kgs. Okay, he can gain more than 12 kgs, but his target is to gain at least 12 kg, at least 9 kg, and at least 8 kg. I hope this was clear to you, everyone. uh, Vijayang, Vijayan. Okay, was it clear? Can I get a confirmation, a quick confirmation plus one in the chat box? Okay. Okay. So over here, let's quickly find out the output for this test case. Okay. So basically, what I'll be doing in order to gain some weight, no, you should not be working a lot that at the end of the day, even though you are eating some food, you will not be gaining some weight. Okay. You should not be losing weight on that particular day. If you are targeting to work on the particular ith day, then the resultant of ith day should be positive in terms of gaining weight. Okay, so what I'll be doing, I'll be creating one array. That array will be, let's say, it is called a temporary array that denotes that if I'm working on the ith day, whether I'm gaining some weight or I'm losing some weight. So that would be nothing but the difference of gain and loss. So 6 minus 2, that will give you 4. That means on the first day, you will be gaining 4 kg of weight at the end. For 9 and 4, for the second day, 9 minus 4 will be equivalent to 5. So this denotes on the second day you will be gaining 5 kg. 2 minus 3 will be minus 1. So negative indicates that you will be losing your weight. You will be losing your weight if you are working on that day. 3 minus 4 will give you minus 1, and 4 minus 5 will give you minus 1. So now you simply need to iterate over this temporary array and we can figure out our answer. Let's say what is query I. Now let's say 8 kg. Now I want to gain 8 kg. So if I'm working on the first day and second day, I'll be gaining 4 plus 5 will be equivalent to 9. So this value is at least greater than 8, right? And this is the least number of days that the pig will be working on, right? If he works on the this day, then his weight will be reduced by 1 kg. So 9 minus 1 will give you 8. So but the number of days will be increased by 1. Over here, how many days he is working? He is working only 2 days. Okay, nowadays it is happening that whenever I try to open my link of GFG article or anything, then GFG premium page opens. Okay, Shivam, okay. I'll inform the team regarding this issue. So was this part clear? A quick plus one in the chat box. I haven't got any reply from the audience whether this was clear or not. How you got the answer for the first query to be 2? Okay, for gaining 8 kg, he needs to work only 2 number of days. Now for 9 kgs, let's find the answer for 9 kg. Okay, Okay, that was marker. Okay. So for 9 kg, let's quickly find out the answer for the 9 kg. If he is willing to wait, like let's say he is willing to gain weight equivalent to 9 kg, then you can observe over here, he can work on the first and the second day. So that will be 4 plus 5 will be equivalent to 9. And that value is at least equivalent to 9. His target is achieved by simply working for 2 days. So for the second one as well, the output will be equivalent to 2, that he only needs to work 2 days. Now for 12 kg, let's find the answer for 12 kg. For 12 kg, can he gain the weight equivalent to 12 kg? At least 12 kg. So let's say he's working on the first day 4, next day 5, and now you can observe the rest of the days are not helping him to gain weight, but he'll be losing his weight if he's working on the rest of the days, right? So if you take the sum of each and every day, then it will not be equivalent to let's say 12 or greater than 12. So at max, with this amount of work, he cannot gain weight greater than 9 kg. So for this, the answer will be -1. And this is what the answer is for each and every queries. Please explain question 1 again. Okay, you can watch down the video again. I cannot again go through the question because it's already 1 hour I need to cover. But at the end, if time persists, I will be explaining it again. Okay. So was this part clear? This part, I guess everyone was it clear? A quick confirmation in the chat box, +1 quickly. A quick confirmation in the chat box, +1. Then I'll be explaining you how we can solve this question. Okay, so let's focus on this test case. Okay, so we were able to think of this part that we need to only work on that particular day on which at the end of the day we are gaining some weight. If we are losing weight on that particular day, then there is uh, no meaning of working on that day, right? So now over here we need to work on this temporary array. We were able to find this temporary array with the help of this gain and loss array, and this is the final weight you will be gaining or losing on that particular day. So now in order to find the answer, what we simply need to do, let's say there was some test case in which the overall weight you are gaining on that particular day was something, let's say for some test case the temporary array looked like this: 4, 5, 3, 2, and 1. So this is the overall weight you will be gaining while working on the particular ith day. Okay, so this is the end result. At the end of the ith day, whether you will be gaining some weight or you will be losing some weight. And let's say the queries were, let's say I'll be taking some random values: 7, let's say 10, 10, and let's say 4, 7, 9, 10, 12. Okay, so these are the queries. Okay, so was the part about temporary array clear to everyone? I guess it was clear. If you have any confusion regarding temporary array and this is some other test case. Okay, test case number 2. This is the addition of gain and loss array. That is the end result of that particular day. So now over here, in order to answer query number 7, what you can do, you can observe that you will be always choosing the day on which you are gaining the maximum weight, right? Because you need to minimize the number of days on which you are supposed to work, on which peak has to work, right? Peak has to work. So in order to minimize the number of days, he will only target those days on which he will be gaining maximum weight. So for query number 1, you need the list sum of this temporary integer to be equivalent to 7. So what I'll be doing, I'll be working on this day. and I'll be working on this second maximum day. So I'll be gaining at least 7 kg of weight by this, right? Similarly, if I'm targeting to gain at least 10 kgs, so what I'll be doing, similarly, I'll be taking the maximum value 5, I'll be taking the second maximum 4, so the sum still is equal to 9. It is not greater or equal to 10, so I'll be working on this day. Or let's say you can take the second maximum, third maximum, you can work on this day or this day or this day, right? So let's say I'm working on this day on which I'm gaining the weight 3. So this will be equivalent to 5 plus 9, 5 plus 4, 9, 10 and 12. So you'll be gaining at least 10 kg. Let's say you want to gain weight equivalent to 12. So I'll be working on day, I'll be gaining this day, this day and this day. So this will be 5 plus 4 plus 3. And this will be equivalent to again 12. So for each and every query, the answer is equivalent to 3. And for the first one, the answer is not equal to 3. It is equivalent to 2. So we simply need to target on working on that particular day on which I'm gaining maximum weight. So I need to work in decreasing order of this temporary array, right? And simultaneously, while working on the values of temporary array, what I'll be doing, I'll be taking its prefix. First of all, I'll be sorting this temporary array in decreasing order. Decreasing order because I need to target the day on which I'm getting the maximum weight. I'm gaining the maximum weight. Okay, so was this part clear? The sorting part, why sorting part is required? Because we have to minimize number of days. So I'll be first of all sorting. So after sorting, the temporary array looks like this. This will be 5, 4, 3, 2, 1. And now, let's say, now this is what I have got after sorting, right? And this is our query. 7. Okay. This 7, 10 and 12. So now in order to find out the least number of days, what you can do, you can iterate over this temporary array from the first index, and whenever you get a sum greater than or equal to this query of I, you will stop. Let me repeat. Now in order to find the least number of day for each and every query, on this sorted array, sorted temporary array, you can start the iteration from the 0th index and keep on adding the value, that is the weight you are getting in a sum variable, and as soon as your value of sum is greater than or equal to temp, or let's say is greater than or equal to your query, just stop, and whatever is the count of days, that will be the answer for that ith query. But this approach will take too much amount of time. Why this approach will take too much amount of time? First of all, we need to figure out what will be the time complexity if I am doing it for each and every ith query. So let's say for the ith query, let's say there was a worst case in which each and every query was equivalent to the sum of this temporary array. Let's say 5 plus 4, that would be 9, 9 plus 1, 10, and 10 plus 15. Let's say all the queries were equivalent to 15 or greater than 15. Okay, 15 or greater than 15. So in order to find the answer for this query, you need to iterate over the entire temporary array. In order to find the answer for this query, you need to iterate each and every number. So each and every query, you will be having an iteration over the temporary array, and that iteration will be on that entire array, that is on the size of the array. And this value will be equivalent to the input number n. So for each and every query, you will be iterating n number of times. So the overall time complexity will be equivalent to q into n. Q is the total number of queries, and this is quadratic. Yes or no? Plus you will be sorting, right? You will be sorting the temporary array, and that will take n log n. Let's say you are using inbuilt function and that uses merge sort. So this will take around n log n, and let's say what will be this number, the larger number q into n, what can be its value? So q can be equivalent to 10 to the power 5 and n can be 10 to the power 5. So 10 to the power 5 and 10 to the power 5. So total 10 to the power 10 iterations, and this will not give you AC. because this is not allowed in 1 second. Okay, the time limit for this is equivalent to 1 second. We can solve it in a better manner with the help of something extra. Okay, we can still optimize this approach. You can try solving this approach, but this approach will not get accepted, or if it got accepted, then okay, so the time limit will be more than 1 second. Was this part clear? But we can do better than q into n. Was this part clear? A quick plus one in the chat box. And the space complexity for this will be order of n, because you have created a temporary array, and this size of this temporary array will be equivalent to n. So this is your time and space complexity of this first approach. Was this part clear? A quick plus one in the chat box. Okay, thank you. Thank you, Ankit. Thank you. Update yourself. Okay, I can see 33 of you are watching, and I'm getting only few of the replies. Is my internet connection slow or what? Okay, so I think can I get a confirmation from everyone? A quick plus one in the chat box, quickly. A quick reply. Okay. So I can do better than this. So you will be saying like how you can do better than this. Okay, so let's understand. So here, why were you required? Like, what was the need of iterating over this temporary array? In order to answer the ith query, you were iterating over this temporary array in order to find the sum. What is sum? Sum is the addition of the values of temporary array. So can't I create a prefix array? Can't I create a prefix array? Because prefix arrays already gives you the prefix sum. So at the end, you were iterating over this temporary array and calculating this sum and stopping the iteration as soon as your sum is greater than or equal to query of 5. You were stopping as soon as your sum is greater than or equal to query of 5. So what you can do, you can create a prefix array of this same temporary array. Let's say this is my temporary array and I'll be creating a prefix array. So how will that help us? Let's understand. Let's say I've created a prefix array, and that prefix array of this will be containing 5, 9, 12, 14, and 15. Okay, so I've converted this temporary array, and now I'll be working on this prefix array of temporary array. I have made the same change in the same array. No, I have not created a new array. Okay, and let's say the queries were equivalent to, let's say one was 15, one was 7, one was 9, and one was 12. So now in order to answer each and every query, Now, in order to answer every query, what I will be doing, I will be simply finding a value which is just greater than query of 5. If I want to gain 15 kg, I'll be finding on this temporary array the value just greater than or equal to 15. Just greater than or equal to 15. For 15, I can get a value greater than or equal to 15. On which index? On the last index. So the indexing will be zero based indexing. Don't worry. So whatever index you are getting, just add 1 to it to get the total number of days you need to work. So 4 plus 1 will be equivalent to 5. Now for 7, if you want to gain weight equivalent to 7 kg, find a value which is just greater than 7. So over here you can observe 9 is the value just greater than 7, and its index is 1. Just add 1 to it, because it is zero based indexing. You will be getting the count of days. You need to work only 2 number of days. Now for 9 kg, do the same thing. A value just greater than or equal to 9. I can find it at index 1, plus 1 to it to get the number of days, and I'll be getting 2 as the answer. Now for 12 kg, just a value greater than or equal to 12, I can get 12 itself at index number 2. So 2 plus 1 is the count of days, and I'll be getting 3 as the value. So this is how I'll be getting the answer for each and every query, by simply finding a value that is just greater than query of 5. Yes, exactly, Rani Pawan, exactly. Okay, so that idea came, the prefix sum idea I thought of the prefix sum with the help of this. पहले मैंने क्या किया कि मैंने एक अप्रोच निकाली जिसमें ये था कि मैंने सॉर्ट कर दिया ओवरऑल गेन और ओवरऑल लॉस को, ठीक है, कि ओवरऑल एट द एंड ऑफ आया डे वेदर आई एम गेनिंग सम वेट और आई एम लूजिंग सम वेट। तो फिर उसको सॉर्ट करके ऑप्टिमल आंसर चाहिए था, क्योंकि मुझे लीस्ट नंबर ऑफ डेज चाहिए, राइट, आई नीड लीस्ट अमाउंट ऑफ डेज ऑन विच द पिग नीड्स टू वर्क। तो in order to minimize the number of days, what did I do? I only selected those days on which I was gaining maximum weight. First I'll be selecting maximum, then second maximum, then third maximum, in order to minimize number of days, right? तो उससे मुझे आइडिया है कि सॉर्ट करना चाहिए इस टेम्पररी एरे को इन डिक्रीजिंग ऑर्डर। सो डिक्रीजिंग ऑर्डर पे सॉर्ट करने के बाद अप्रोच लगाई, तो मैं इटरेट कर रहा था, आई वाज इटरेटिंग ओवर दिस टेम्पररी एरे एंड आई वाज only iterating until and unless my sum value was greater than or equal to query of I. So I simply need to find a value that is just greater than the query of I. So from that I thought, if I was iterating every time for every query, I was iterating over this temporary array. In worst case, the time complexity came out to be q into n. So can I directly get that value just greater than query of I can be found in the temporary array or not? So from that I got an idea that I can use prefix sum, because the thing which I was finding was the sum of the values in this temporary array. Okay. From that I got an idea I can use prefix sum, and in order to get the answer from the prefix sum very quickly, you can use the concept of binary search. You can find a value that is just greater than query of I. Okay, I have summarized the entire approach. Okay, Vijay. I will not mix Hindi. Yes. So now here comes the part where the temporary array can be containing negative values, right? There can be a test case where you can observe. So how will you handle? So for that part, what I'll be doing, I'll be simply inserting those values which are positive inside my temporary array. Okay. So basically, only positive values. Here in this temporary array, you can observe there are negative values, right? So if you take the prefix of this prefix sum, 4 plus 5 will be, first of all, sorting. So after sorting, the array will be 5, 4, negative 1, and negative 1. Now I take the prefix sum, it will be 5 plus 9, and the value will eventually start decreasing, right? So what I'll be doing in the temporary array, only include the values on which you will be gaining some weight. Only include the positive values. So your temporary array in this test case will not contain negative values. It will only contain positive values. 4 and 5. Now sort this array. 5, 4. Take its prefix sum. Right? Because working on a day on which you are not gaining and losing the weight, that is not the target of peak, right? Peak's target is to gain some weight. So we'll be excluding those days on which he's not gaining any weight. 01 knapsack. Okay, so Vaishnavi gave us an idea that can't we use the recursion approach with 01 knapsack concept. Okay, and I tried it, but it was not able to get the correct answer. Okay, Manas, regarding the leaderboard, I'm not sure why you are not getting the uh, leaderboard part. Okay, these are the submissions. Okay, so isn't it updated, this leaderboard? Okay, so regarding that, this technical part, I'll confirm it with the team, and it will be resolved soon enough. So Mansi was saying that complexity of knapsack approach will be n to the power 2. So 01 knapsack, you need to answer every query. No, you need to answer every query. Let's say For this query, you will be checking for each and every possibility, whether I can include it, whether I can exclude it. So that would be for each and every temporary element, you will be having two possibilities, for this two, for this two, for this two. And let's say how many combinations you will be trying out. This will be the amount of combination, that would be 2 to the power n. So this will be a very large number, and you have to take the minimum number of days. So whenever you reach a possibility that okay, I have selected 3 days and that value is greater than query of I, then keep a global maximum or something like that and compare it the number of days. Okay, Mansi, you can try out in that manner, and you need to memorize that solution. And after memorization, take a look what will be the time complexity. You can do that in after memorization, I think, if memoized also. Okay, so I think Shivam has already tried. He says after memoization it will be q into and square. Okay, okay. So okay, you are getting TLE for POTD. Okay, so if, uh, let's first of all get the solution for this question done, and then we'll be discussing if we have time for the POTD. Okay. So was this part clear? And now, in order to find the answer from the temporary array, I will be using the binary search. And what I will search for binary search, you need some key and you need a sorted array. So sorted array is already in hand. So this temporary array was also already sorted, and we also converted it into prefix sum. So prefix sum array is always sorted, right? If there are only positive values in prefix sum array, and then you find out the prefix sum of that array, the array is always going to be in sorted manner because it is containing the addition, right? So now on this prefix sum array, I will be using binary search. So for binary search, you might be aware that I need a key. So over here, what kind of value are you looking for? What kind of key do you want? You want the key. Let's say that would be temporary of I. You want the key just greater than just greater than what? Your query of I. Okay. So you simply need to find a value inside your temporary array. So from this you can say that if temporary of I is greater than or equal to query of I, then the value present at I minus 1th index inside your temporary should be lesser than your query. And temporary of I minus 1, if that value is lesser than query, then the I is the count of days. Then and answer is I plus 1. Why I plus 1? I denotes the index. Total number of days can be obtained by adding 1 to the index. Index is zero based indexing. So you simply need to find a value that is just greater than query of I. That is just greater than query of I. Just a minute. So you simply need to find the value temporary of I is greater than or equal to query of I, and temporary of I minus 1. That is the value on the left hand side of I should be lesser than query. Sorry. Okay, so you can observe that inequality everywhere over here as well. You can observe it. Let's say for query of I is 15. This is 15. For 15, you got the index to be 4. You can observe if I am saying that this is I, this will be I minus 1. This value is lesser than 15, right? For 7, you'll be getting the index to be 1. You can observe its previous value is always lesser than 7. So you simply need to find such an index where the I minus 1 value is lesser than query of I, and the value you are getting should be greater than or equal to ith query. Another way to avoid binary search would be sort gain of I minus 1 in decreasing order and sorting the query in increasing order. Okay, sorting the query in increasing order, queries are offline and do prefix sum while answering the queries. Why do you need to sort the query? Because uh, if you sort the query, like there is no meaning of sorting the query, there is independency of queries, like the answer will be the answer for 7 will not affect the answer for 9 or 12. So sorting the query, it does not matter if you first of all find the answer for 12 or if you find the answer for 15. Okay, so you are saying that sort the queries. Okay. 7, 9. Okay, I'm getting. You are saying that 7, 9, 12, and 15. Okay, okay. So you are saying, okay, so we got an interesting approach from Ankit. He's saying that instead of using the binary search, you can directly sort the first of all query. And after sorting the query, obviously the next value will be greater than the previous one. So you can either include the next one or you can exclude the next one, right? Okay, yes, that is also a very good approach, uh, Ankit. Nice. Okay, I don't think that approach will fail for anything. Okay, so was that approach accepted, Ankit? Was your approach accepted? Was your approach accepted? If it was accepted, then that's really great. Nice. That's really great. Okay, you can use binary search as well, and the approach mentioned by Ankit is also a very good approach in which you can avoid binary search. You simply need to sort the query, but see over here, if you sort the query, no, then you need to map this value with that particular index, and whenever you return the answer array, no, you need the answer for this to be at that same, if because that would be mapping for the ith query, the answer will be mapped for the ith query. Okay, so that approach, okay, so let me explain. Okay, so we need some kind of mapping as well, right, Ankit? You mapped the original query elements with the index. Okay, let me repeat this approach. So this temporary array, we already have this temporary array, okay, and this temporary array is sorted in decreasing order. Okay, so this temporary is difference of gain array and loss array, gain of I and loss of I. Gain minus loss of I, right? Now, and here is our query array. Here is our query array. Let's copy this part. So he was saying that after finding the difference of gain and loss, what you need to do, you simply need to sort this query in increasing order. In increasing order. So if you are sorting it in increasing order, that would be 7, 9, 12, and 15. So now start applying the summation. First of all, find the answer for the first query. For 7, you will be iterating over this temporary array. Let's keep some variable. Let's say we have a sum variable initialized as 0, and let's say we have our okay. So we only simply need a sum variable. Now I am iterating. So the sum will be equivalent to 5. So now that 5 is not greater than 7, increase. So 4, so 5 plus 4 will be equivalent to 9. So I can see this value is greater than 9. This 9 is greater than 7. So I'll be marking this index. This index is equivalent to 1, right? This is 0, 1, 2, 3, and 4. So for this, I got the answer at the index number 1. The sum came out to be equivalent to 9, and 9 is greater than or equal to 7. So for this query, the output will be the index plus 1. 1 plus 1, that would be 2. And I'll be using some pointer to mark this location, that I have found the sum till this location. And now whenever I see a value, I found the next query to be equivalent to 9. So what I'll be doing, instead of iterating over this temporary array and keeping on adding some values to my sum variable, I'll be first of all comparing the value with sum. If the sum is already greater than or equal to your query of I, then simply return this index plus 1. Let's say this index is called as I, then return index plus 1. So I plus 1, for this as well it will be 2. Now for 12, check the value of sum. 9 is not greater than or equal to 12, so move the value of I further. So 9 plus 3, that would be equivalent to 12. So your pointer is currently standing at the index number 2. And now at this index number 2, what you need to do, this will be your index plus 1 will be your answer for this 12. 2 plus 1 will be 3. Now the next query is 15. So for 15, first of all check 12 is greater than or equal to 15. No, move the value of I further. So 12 plus 2 will be 14. Still not greater than 15. Move the value of I further. I is currently standing over here and it is equivalent to 15. And now at this point, just return the index plus 1 as the answer for 50. So that would be 4 plus 1 will be equivalent to 5. So this was the approach mentioned by Ankit. No, no, it will not be order of n. No, it will not be q into q log. Q log q. If you sort the queries, the time complexity will be queries. Okay, so q into q log. Why q into q log? Okay, q into q log plus n for iterating over the temporary array. And the old solution is order of q into log n plus n log n, right? Okay, the older one was n log n. So first of all, let's differentiate the time complexity of both the approach. Okay, so the one which is mentioned by Ankit and the one which we are using with the help of binary search. Okay, so for this approach, first of all, I need the temporary array. For temporary array, a simple iteration that would be order of n. Now, in order to sort this temporary array, it would be n log n. Now, in order to sort this query array, it would be q log q. Let me write down over here. So first was for temporary array, sorting the temporary array n log n, sorting the query array q log q. Now, in order to find the answer for each and every query, you will be at worst only once iterating over this temporary array, only once. So that would be one iteration. So n and q can be equivalent according to the question. You can observe q and n can be equivalent. Let's take it to be order of n log n. And now what about the space complexity? One temporary array was required. And do we need something? No, nothing else, right? So the space complexity will be equivalent to order of n. So this is the time complexity mentioned by Ankit, in which no binary search is used. And now with binary search, let's see with binary search. For binary search, in this we need a map. Yes, we need a map. Yes, exactly. That part needs to be done. So overall space complexity will be increased by something. Okay. So mapping, let's say you use the map, so that would be order of n plus n. Okay. So this mapping between query and the answer needs to be done, and according to that, a new array needs to be generated. Exactly, new array. So this mapping requires, so little bit of space will be used. Okay. That space will be order of n. Okay, so now quickly let's analyze the approach in which we will be using the binary search. Okay, so we, and then it will be your call, whichever approach you are comfortable with, you can try out that approach. Okay, there will be only a difference in the space, while the time complexity, let's say, for the binary search we need the temporary array, so that for that n, and then we need to sort the temporary array, that would be n log n. And what else do we need? Are we sorting the query array? No, we need prefix array. Right? So q log q will be reduced down to order of n. Okay. In this approach, q log q was for sorting the query array, and prefix sum will be order of n. Now for each query, I need log n, right? Because binary search for each query. So that would be q into log n, right? So here we don't need any kind of mapping, so time space will be only occupied by this temporary array, so that would be order of n. Let's compare side by side whichever approach is a better one. Obviously, in terms of space, the first approach in which you will be using binary search is a good one, but the space is linear in both of them. Okay, you can observe this n log n part is same in both of them, but there is a difference in this part. Here it is q log n. You can take it as n plus q log q. You can call this n as q as well, because n and q can be equivalent, right? So overall this will be around, you can take it as n log n. Both the time complexities are n log n, and the space complexity of the first one is order of n, while the space complexity of the second one will be equivalent to 2n. It will be 2n. Not, there is not much difference in both of them, because q and n, if you take the value to be equivalent, then this is what you get as the time and space complexity. Was this part clear? A quick confirmation in the chat box. A quick confirmation, yes or no? Was it clear? Plus one in the chat box. A quick confirmation. And then we'll be moving towards the solution, but let's quickly code this part. Okay, so I'll be coding the part which in which I'll be using the binary search. Okay, and then we'll be quickly moving towards the last question of this session, of this contest. And then, okay, so the algorithm. Okay, I'll be quickly writing down the algorithmic steps in which you need to use binary search to reach down the solution. Okay, so first of all, you need a temporary array. Temporary of I is nothing but gain of I minus loss of I. Now, what else do we need? After getting the temporary array, sort the temporary array. Okay, after sorting the temporary array, what do I need? I need to find the answer for each and every query. I'll be iterating over the array query. I will be iterating over the query array. Okay, and now for each and every query array, I'll be calling the binary search on the temporary array. Okay, so prefix sum part needs to be done right after sorting. So the third point will be not answering the query. It will be first of all getting the prefix sum. Prefix sum on our temporary array. Okay, and then here comes our query part in which we'll be answering. I'll be calling the binary search on the temporary array, and I'll be searching for query of I. And it will be returning me some index, let's say idx, and whatever index it is returning, if that index is not equivalent to -1, if that index is not equal to -1, let's say for some of the now in order to store the answer, I need an answer array as well. So that answer array, let's say, assume it has already been declared over in the beginning, and its size equivalent to n. And similarly, a temporary array, its size is equivalent to n. And let's initialize this entire answer array. You can initialize the entire answer array, or you can leave it as it is. But let's say this answer array was not initialized. So what I'll be doing, if idx is not equal to -1, if idx is not equal to -1, then inside the answer array for ith query, the answer will be idx plus 1. Okay, and if this is -1, then answer of I will be equivalent to -1. This will be your entire algorithm for this question. Was this part clear? Now, is it clear code for second approach? Okay, the one which you mentioned, that one, you already know that approach, no? Do you want an approach from me as well? Yes, you can solve this questions after the contest as well. Okay, I guess, yeah, you can go to past contest and practice the questions over there. Okay, so this is what we need to do. So step by step, let's quickly write code this part. Or do you want me to code this part from scratch, or I already have a solution and the time is already 10:06. So what do you want me to do? Because we have still one question remaining. I'll be doing, but I need everyone at the till the end of the session. If you want me to code the part, then it will take a little bit of time. Let's quickly code it. I'll be taking only 5 minutes to code. Okay, so first step was to create a temporary array. Now we need to first of all figure out whether you need a long data type array, that is long in C++, or you need an integer data type, because you are going to figure out, you are going to create a prefix sum of your temporary array. So you can observe the loss and gain array. Let's say loss array contains 0, so our gain array will be at max equivalent to 10 to the power 9. And now at max in the prefix sum, it can have the sum of every value. Okay, let's say in worst case, your gain array contains everything equivalent to 10 to the power 9. 10 to the power 9, everything. Okay, and your loss array contains 0 everywhere. 0, 0, 0, 0. So your temporary array will contain 10 to the power 9 everywhere, right? 10 to the power 9 everywhere. And now you will be taking the prefix of it, prefix sum. So the maximum value of this can reach in worst case. You need to find out what can be the maximum value of n. N can be 10 to the power 5. So the sum of this entire array will be 10 to the power 5 into 10 to the power 9. So that would be 10 to the power 40. So this value can only be stored in long, not in int. So the data type of this temporary array will be equivalent to long. In case of Java, you will be using long. In C++, long. Okay. Okay. So I got an answer. Just use the lower bound. Okay. So, but in yes, predefined method can do a job Megatron, but in Java you don't have the inbuilt function to find the lower bound and upper bound. Okay. So you need to write down that from scratch. Okay. So I've already written down an approach for this. So just a minute. Let me share that part. Okay. So here is our and a solution, the one which I have already written down the code of. Okay, if you are using C++, you can use the inbuilt function lower bound, upper bound, right? But over here, if you are supposed to write down the binary search, this is how the binary search looks like. Okay, it seems long enough, but it's very simple and very easy to understand. Okay, so first of all, what I have done, I have not created a, I have called it as a profit array. This is my temporary array only, but I'm calling it as profit, whether I'm gaining some weight or losing. And it is arrayless because I will only be working on those days where the at the end of the day I'll be gaining some weight, right? Positive values, positive value of the difference of gain of I and loss of I. So I've created an array list. I'm not sure how many values will be positive. So array list. You can use vector in your C++. Now what I have done, whenever I can see gain of I is greater than or equal to loss of I, only at that time I will be including that in my, let's say equal to is also not required, but let's say I've kept it for some reason. So what I'll be doing, I will be adding it in my profit array. Now I have sorted it in reverse order, that is in decreasing order. Sorted the array in decreasing order. Now what I'll be doing now, this is the part in which I am doing the prefix sum of the profit array. And now I need an answer array, that is going to store my answer for each and every query. And I have filled with -1. You can fill it with -1 or you can keep it as it is. Now I'll be answering each and every query. Now there can be a query in which you can observe inside this constraint it is mentioned that query can be equivalent to 0, query of I. So if that value is equal to 0, then you don't need to work on any of the day. You don't need to work on any day because the least amount of weight you need to gain is 0. For 0, you need to work on 0 number of days. So I have kept the answer to be 0 for that. Else, if this is not the case, I'll be looking for a value which is just greater than query of I inside my profit list. So that value will be returned and it will be stored. It will be an index IDX. If that index is not -1, then that means answer was possible. And if it is not -1, then what I'll be doing? I'll be increasing the value to get total number of days, and answer of I, that is answer for that particular query, will be index +1 and return the answer. And now here is our binary search. It seems lengthy enough, but let's quickly go through the binary search. Over here, key is nothing but value just greater than query of I. This is my key. This is my let's say query of I is the key, and what I am looking for is the value that is just greater than query of I. I'm looking for a value that is just greater than query of I with the help of binary search. So now this is the size of the array list which I have created. This is low and high. Obviously n is equal to the size of this array list, and this is my query. I'm looking for a value which is just greater than key. So now it can be possible that the key value will be greater than the sum of the entire profit array. So in that case, answer will not be possible. So I've handled that case itself over here, simply written -1. If this is not the case, it is possible that the key value can be small enough. It can be such a small number that you don't need to work. You simply need to work on the first day. You simply need to work on the first day, and your entire thing will be done. So I have handled that case as well. I'll explain you why I have handled both this case separately. If this is not the case, I'll be applying the binary search, mid low plus I divided by 2. And now here is the part that I'll be, if my mid value is greater than or equal to key, and my mid -1 is lesser than key, then that is the exact value, that is the mid value which I was looking for. So I need to check that it is possible that the mid can be at some point equivalent to 0. When mid is 0, and when mid is equal to 0 is your answer, at that time this comparison will not work. So that is the reason I handled this part before moving into this while loop. Okay, so I have handled this part separately outside the while loop. When your answer is equal to 0, that is index 0 is the answer, then at that time this condition will not be satisfied because mid -1 should be greater than or equal to 0. Else, if your key is greater than your mid, then move towards the right partition. If your key is lesser than your mid, move towards the left partition. And that's it. And at the end, generally, this condition will not be reached. And if this is reached, then that means answer was not possible. Return -1. Okay. So was it clear? Query of I is greater than profit of. Okay. So to save time, you can add a condition where query of I is greater than query of I is greater than. Yes, I have handled that part inside the function. Okay, Harmandeep. I handled that part inside the function itself. Okay, so a simple function call, and inside that, an if condition is there that will just stop from going into the binary search part. So now let's compile and run quickly, and let's get this accepted. Okay, so the first one was accepted. Now let's try to submit and see the solution. So was it clear? Can I get a quick +1 in the chat box if this part was clear? A quick +1 in the chat box for the same. paste the code in chat box. Okay. Okay, so let me copy this part. Okay, I'll share the link of every solution in the chat box. So can I get a quick confirmation +1 in the chat box if it was clear to everyone, and we'll be moving towards the third question. Okay, just mention it down in the chat box if it was clear. The last question. Okay, I see no doubts coming, so I think it was clear to everyone. And now let's quickly read down this problem statement, Geek's birthday party. Okay, so the problem statement is like there will be a graph given to you. Okay, so Geek is throwing a party on his birthday where he will be inviting M friends to play a game. The game consists of an undirected tree with n nodes and exactly n minus 1 edges. Okay, so n minus 1 edges itself denotes that there won't be any kind of cycle. Okay, the geek can either place one of his friends at each node or have an unlimited amount of snacks. Okay, at each and every node he can either place a friend or he can place an unlimited amount of snacks on that particular node. Now to complete the game, everyone is playing a game. So now in order to complete the game, everyone, each of geek's friend should move towards the root node. Root node is the node having value 1. Everyone will start moving towards the root node while also grabbing snack if they are following the path to the root node, and in that between, if they encounter a node where some snack is available, then they will be getting that snacks and they will be eating that snacks. Now it's the geek's job to find an arrangement of his friends such that the total number of times snacks enjoyed by all of his friends is maximized. So he's trying to make all of his friends happy, so he will be making such an arrangement that everyone will be gaining. In total, everyone will be gaining some snacks, and the total sum of snacks gained by every friend will be maximized. Okay, so that is what the question says. It sounds little bit difficult to understand, so let's quickly understand this part. So what I'll be doing, there are n number of nodes given to you. Okay, so according to the test case, let's take this first one. N is equal to 7 and m is equal to 3. So n number of nodes and m is equal to 3. This denotes the number of friends. So this is my root node. I'm just drawing a random tree. 1, 2, 3, 4, and 5, 6, 7. And let's say this is the tree in which there are n minus 1 number of nodes. And now there are m number of friends, 3 friends. So what I can do, in order to maximize, let's say if I'm placing a friend over here, now his target is to reach the root node. His target is to reach the root node. So at each and every node can contain either a friend or it can contain some snacks. So let's say snacks was present over here. So I'm not marking snacks with anything. So if nothing is mentioned on that particular node, imagine there is a snack present. So he is trying to move in the upwards direction. So let's say snacks was present over here and over here. So he'll be gaining 2 times. He'll be getting snacks 2 times. So now let's say there was one more friend placed at this node 6. So he'll be moving in upwards direction. He will be also getting snacks twice. And now let's say the last friend was placed over here and snacks was present over here and over there. So he will be also gaining the snack twice. So in total, how many times were was each and every friend getting the snack? In total, 2 plus 2 plus 2 will be equivalent to 6. So the output will be equivalent to 6 in this case. Okay. So at each and every node, either a friend can be placed or a, let's say, a box of snacks can be placed. Was the question clear to everyone? A quick confirmation in the chat box. Do you want me to explain with one more example? Was there anyone who was not able to understand the question? Okay, I think it was clear to everyone. Okay, so let's move forward. So now what can be the approach for this part? Okay, so the answer for every test case is somewhat fixed. Okay, what I'm trying to say is that For given binary tree, for this is not binary tree, for the given graph or for the given tree, the answer is always fixed for the particular value of m. The maximum answer is always fixed. So let's see what I'm trying to say. So let's say m was equivalent to 3. So the optimal way to place all the friends will be like this. Place it on the leaf node. Place it at the leaf where you won't find any kind of nodes in the subtree of that node. Okay. So let's say if this was not the case and if I tried a different arrangement and I placed a friend over here for m is equal to 3. One friend is placed over here, here and here. Now everyone is going to move in the upwards direction. They will try to reach the root node. So this friend will try to reach the root node, and let's say snack was over here. Snack was present on all the other nodes. Let's assume. And everyone will only move in the upwards direction. Okay, so for this friend, he will gain snacks only once. And for this friend, he will be trying to move in the upwards direction and he'll be gaining snack at the root node only. And for this friend, he'll be gaining the snacks over here and over here. So the sum overall will be 2 plus 1 will be equivalent to 4. So this is not an optimal approach. So the optimal approach says that if you are placing a friend on this ith node, on the particular node, then don't place any snack on the subtree, on any of the node in the subtree of that friend. Okay. So every time try to place the friend at the leaf node, at the bottommost level of your tree. Okay, so this was the optimal way. So the optimal way for m is equal to 3 will be placing friend over here. So snack will be present over here and everyone will be gaining snacks twice. So overall sum will be 2 plus 2 plus 2 will be equivalent to 6. Okay, so from the observation it's clear that place the friend at the bottommost node possible. Okay, and you might be saying that okay, every time I will be checking the bottommost, but that's not always true. What I'm trying to say: 1, 2, 3, 4, and 5, 6, 7, 8, and over here let's say it's 9 and 10. Let's go 6, 9 and 10. This is the structure of the tree, and let's say m value was equivalent to 3. So over here you can pick the bottommost, that is at the most depth, the node which is having the highest depth. So these are the nodes. So everyone will be gaining snacks over here 1, 2 and 3. So each of them will be gaining 3 times. So the answer for m is equal to 3 will be equivalent to 9. So now let's one by one increase the value of m. M is equal to 4. So where should I keep the other friend? So as I mentioned, the bottommost. So let's say if I'm placing a friend over here, will that work? So if a friend is placed over here, then the value will be reduced. So everyone over here will not gain snacks thrice, but they will only get snacks twice. 2, 2, 2, and this one will also get 2. So 4 into 2 will be 8. Can I do better than this? Can I do a better arrangement? Let's say if I'm not placing it over here, if I'm not placing over here, then what? I'm placing a friend over here instead. So this will be getting once, this will be getting thrice. So this would be 3 into 3, 9 plus 1, that would be 10. So I'm getting a better arrangement. Okay, so every time try to place a friend at such a node on which where you will not find any of the friends placed in its subtree. Okay, so over that node you can place a chocolate. Okay, was this part clear? How the arrangement works? And you might be saying that for m is equal to 4, you can place it over here also. This will also work. You can place it over here also, but not on this both. Because if you place on this node, and in its subtree there are friends placed, right? So you that won't be a better optimal way to place the friend in order to complete the game. Now I have solved for m is equal to what was the thing, m is equal to 4, and the output came out to be 10. So now let's take one more longer value. Okay, so can you say for m is equal to 5, where should I place my friend? On which node? Either on this node, this node, this node, this node, or this node, or this one. Where should I place my friend for m is equal to 5? Four of them have already been placed at an optimal position. So for m is equal to 5, where should I place them? Anyone from the audience? Where should I place? Should I place it at the node number 2, 4, 7, 5, 2 or 5? Yes, exactly. So you can place it at any of the node, either 2 or 5, because both of them will be contributing 1 to your answer. So for m is equal to 4, you are getting, what is the answer for m is equal to 4? You are getting, you got m is equal to 4, you got answer 10. And now one more friend, let's say I'm placing it over here, so we'll be gaining one more snack. 10 plus 1 will be 11. Okay, similarly for m is equal to 6, for m is equal to 6, I can choose the node number 5. I'll be placing it over here. So 11 plus 1 will be equivalent to 12. For m is equal to, let's say 7. And now here you will be able to observe m is equal to 7. Where can you place? For m is equal to 7, you have only this many positions remaining: 1, 4, and 7. So if you place it over here, no, if you leave some gap between the friends in the subtree and the current node, then it will not be beneficial. It will not be an optimal way. Let's say if you are placing the friend over here and snacks is over here. So this last three of them will be gaining only twice. Okay, and this friend will be only gaining once, and this all are already gaining once, right? So that would be 1 plus 1 plus 1 plus 1, 4 plus 2, 6, 8, and 9, 10. That answer will be equivalent to 10, but you can do in a better way. You can do it in a better way. So where should you place it? So place him at the node number 7. So placing him at node number 7 will be very beneficial. Okay, so node number 7. So snacks over here. This is also a friend. And the value for this one, he'll be gaining only once. He'll be getting it twice. So overall answer will be equivalent to this. Both of them will be gaining twice. All of them will be gaining twice. And he will be also getting. So this is 6, 7, 8, 9, 10, and 11. We got 11. Earlier I was getting 10. So place it in this manner. Okay. 11. So what I'll be doing, so in order to find the answer, you might have understood that, okay, so uh, I can simply iterate over some predefined set of values, on some predefined set of values, and I'll be getting the answer for any value of m. Okay, and in the question, what is the possible value of m? The inequality between n and m. N and m can be equivalent, right? And if m is equal to, let's say, 8, then you will be getting some other answer. If m is equal to 9, you will be getting some other answer, and m is equal to 10. That is total. Now m, when m and n, both of them are equal, at that time, if entire tree contains friend, then there won't be any snack. So at that time the answer will be 0. So this is going to be our base condition. I'll be checking this base condition in the beginning, and if this is the case, now in order to imagine the tree in this manner, you first of all need to construct an adjacency list of the tree. Because in the question, if you observe over here, in the question, you will be given an array, a 2D array that contains two columns and n minus 1 number of rows. That array is called edges array, that only denotes the edges. Okay, so first of all, I need an entire adjacency list in order to represent it as a graph. Was this part clear? Any doubt till now? Yes or no in the chat box? A quick confirmation regarding this. A quick +1 in the chat box, everyone. Okay, if you have any doubt, just mention it down. Okay. Okay. Thank you for the confirmation. So now, what I'll be doing from this, you might have understood that there is some specific structure. Okay, that the optimal way to place friend is to simply target the uh, least node, right? The node which are at the bottom, and in its subtree, try that not, the entire subtree contains friends, or the entire subtree contains nothing. Okay, if the entire subtree contains snacks, then that won't be efficient. You simply need to target those in which the entire subtree contains friends, just like this one. Okay, so what I'll be doing, I'll be finding a value that will be, first of all, you, let me just clear this out. Let's see what can be the maximum answer for each and every node. The maximum answer for each and every node will be its depth. For this, the maximum answer will be 1. That is its depth. Let's say this is level 0, level 1. Okay, if you take 1 based indexing, then that would be depth minus 1. Depth will be 1, this will be 2. So depth minus 1 will be the maximum answer for every node. This will be 2, right? 1, 2. This will be 3. So now, somehow, if we are able to find out, somehow, if we first of all target, let's say m was equal to 4, so what I'll be doing, first I'll be targeting the node which is having maximum depth. So let's say I'll be targeting node number 8, node number 9, node number 10. Okay, so this one will be giving you maximum one. Now let's say I have placed three of the friends. Now one friend was remaining. So where should I place? So here you can observe the maximum depth was equal to 2. So you will be saying that, okay, let's place it on node number 7. But that is not the optimal way. You cannot place on node number 7 because in its subtree, inside its subtree, there are friends placed, right? And this node was containing a snack, and this all the friends were getting some snack from this node. So the answer will be reduced down. So what I'll be doing for each and every node, I'll be finding one value that would be the difference of depth and the size of the subtree. Size of the subtree for that particular node. You will get understand what is the reason behind finding this value. Okay. So depth minus size of the node. What is the size of a particular node? Size of the particular node is the total number of nodes present in the subtree rooted at that node. Okay, so with blue, I'll be marking the size of every node, and with red, I will be writing down its depth. So depth is already written, and now with blue, what I'll be doing, I'll be writing down its size of the subtree. Its depth is equal to 0 because it is at the root. So size of the subtree with blue. Okay. So what is its size? It is 1. For 8, it is 1. Single node contains only one node in its subtree. So its size will be 1. For this, what will be its size? 1, 2, 3, and 4. For this, it will be 1. For this, that would be 4 plus 1, 5. And for this one, that would be 5 plus 1, 6 plus 7 plus 8 plus itself. That would be 10. Is it correct? 3, okay, 4, and this is 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6. Okay, there was no node with value 6. So I forgot the node with 6. That's it. This is 6, 7, 8, and 9. And the nodes are numbered from 1 to n. Okay, nodes are numbered from 1 to n. This is not 10. This is equal to 1.
sorry, 9. This value n is equal to 9 in this case, and m is equal to, let's say, something something you are trying to find out. So now if I take the difference of both the value, if I take the difference of both this value, that is depth minus size of the node for everyone, let's take the depth minus size. So depth minus size for this will be 0. So depth is marked with red, okay? Red minus blue. Everywhere red minus blue. So this over here, red minus blue, that would be minus 4. Over here, red minus blue, that would be minus 2. Red minus blue, that would be 0. And red minus blue, that would be minus 2. Minus 2. Till now, was it clear? What I was trying to find out, depth minus size of the subtree for every node. Can I get a quick plus one in the chat box? I'm happy that everyone is still watching the session and the user are very interactive. That's really great. So can I know, like, as this is the special 100th GFG Weekly Coding Contest, so how many of you consistently participated in at least, let's say, 5 contests? Okay, so that would be at last. Depth is equal to 1, 2, 3, and 4. 4 minus. Okay, sorry. This would be 4. And so the 4 minus 1 would be minus 3. Thank you for mentioning. But can I know how many of you did consistently participated? Let me just recalculate this part. I think we made a little bit of. Okay, so 4 minus 1 is it's correct, and let's mark again. Depth is 2. Depth is 2. This is having 2. This is having 3, and this is having 2, and this is having 1. And let's mark the size. So this will be having size equivalent to 4. This will be having 5. This will be having 1. 1, 1. So this would be 5 plus this would be 9. 5, 6, 7, 8, and 9. And now let's again find the value red minus blue, that is depth minus the size. Now 1 minus 9, that would be minus 8. 2 minus 1 would be 1. 2 minus 5, minus 3. And this would be minus 1. And this would be 1. And this would be 1. Second one, we can just find the prefix sum of array. Find deleted one. Forgot to use long during the test. Okay, don't worry. Okay. Yes, that question was very easy, but there were other circumstances which we need to keep in mind while solving. Okay, so we have recalculated the value depth minus size for every node, and the white one denotes the value. So I wanted to know how many of you have already been participating in the weekly coding contest. Let's say consistently from past 5 contests. Okay, consistently, how many of you participated, sir? For last 4 minus. अरे क्या कर रहा हूँ मैं? 4 minus 1 is equal to 3. Like addition, subtraction. Okay, Megatron says that's really great if you have been participating consistently in every session. Okay, so now what I'll be doing, this values which I have got for every node, what I'll be doing, I'll be sorting them and I'll be storing it somewhere. I'll be storing it somewhere in an, let's say, array list or anything. You can create a list, or as well you can create create an array, because you already know that there are n number of nodes. So let's say I'm creating an array, starting to place all the values 3, 3, 3, 1, 1, minus 3, minus 1, and 2 minus 1, 2 minus 1. Okay. So now if I sort this array, so what I'll be doing, I will be simply targeting on taking the values which will be helping me to gain some uh, finalized answer. So let's say I'm sorting this entire array in decreasing order. 3, 3, 3, 1, 1, and the larger one is also 1, minus 3. Participated but got offended due to wrong question. Quickly, luckily, today all questions were correct. And there wasn't any issue. Okay, so it might happen that someday or sometime, uh, the questions, like, let's say there are some problems in the test case, but we the team is consistently trying to recheck every question before the contest, and they are trying to make sure that no error persists. Okay, but I choked in the special edition. Don't worry, don't worry. These contests are for your, like, let's say, uh, practice, right? Take them as a practice and just try to do your best in the contest, and that would help you in the final interview part or something like that, right? So don't worry now. Just learn from your mistakes of your previous sessions or previous contests, and that, let's say, that would help you to gain confidence. Okay. Now let's say the value of m was equivalent to. Just let me have some water. Just a minute. I'll be back in just a minute. Okay, I'm back again. Okay, so we were finding some. अबे क्या? Okay, so over here, slightly, we need to do the reverse of what we were doing, right? So I found a value that is depth minus size, but now what I'll be doing, accidentally, I did the reverse of what we are supposed to do. That is, depth minus size is not what we are supposed to do. We need to find the size of the node subtracted by depth, and the reason is that because if you focus on the size, then what I'm trying to find out, that I'm trying to find out that how much can this node contribute in my final answer. Is it a better way, it is a better node to include it in my answer or not? So for that, there is a possibility that if I'm placing, let's say, a snack at this point, then I need to check whether this snack will be available by the subtree nodes or not. Or let's say if I'm placing a friend over here, whether this affect on the other friends which are placed in the subtree or not. And for that reason, we need to do size minus depth of every node, not depth minus size, because we need to take or handle the part in which the friends are placed in the subtree as well, right? So accidentally I just did the reverse of what we are supposed to do. We are actually supposed to find size of the node minus depth, not the size of the node minus depth, because the maximum answer can be equivalent to depth of the tree, right? The maximum answer can be equivalent to the depth of the tree, but what about the friends which are placed in that subtree? For them, the value will be decreased by some integer, right? So instead of depth minus the size of the node, I'll be doing size of the node minus depth. So this is my size of the node. Blue one is the size of the node. So I'll be marking it like this. Size of the node minus depth. 1 minus 2, that would be minus 1. 1 minus 2, that would be minus 1. 1 minus 2, that would be minus 1. And 1 minus 4, that would be minus 1. Minus 3. And size 4 minus 3, that would be 1. 5 minus 2, that would be equivalent to 3. 1 minus 2, that would be minus 1. And this is size 9 minus 1 would be equivalent to 8. So this value indicates that how many, if I'm placing a chocolate over here, how many of them can actually get that chocolate? How many can get the chocolate? So over here, if I'm placing a chocolate at this node, there are 8 nodes who can benefit from that chocolate. Okay. So those values I'll be storing it in a list, let's say, and this is not what I'll be storing. It will be the reverse of all of that. Let's say the values stored are minus 3, minus 3, minus 3. And similarly, if I'm placing anything over here, then nothing will be beneficial, right? Because no one is present in its subtree. So minus 3, minus 3, minus 3. Let's say 1, 3, minus 1, minus 1, and minus 1. Now let's sort this part in decreasing order of its value. In decreasing order of its value. 3, 1. And which one is smaller one? Minus 1, minus 1, minus 1, minus 3, and minus 3. And minus 3. And now from this array, you can find the answer for any value of m, ranging from 1 till n. Oh, extremely sorry. Okay, why wasn't it available? Okay, extremely sorry. I was not aware because I am able to see the screen. Are you guys able to see my screen? I hope it is visible now. Okay. Uh, Am I visible to everyone? Is it black, completely blank, or what? Was my OneNote visible to everyone? Just let me reopen OneNote. Just a minute. Okay, now it's visible. Sorry, I was not aware. Accidentally, I was sharing only my window, and that's why it was blank for everyone. Okay, so I sorted it in this manner. And now let's say I want to find the answer for m is equal to 3. For m is equal to 3, I'm clearly sure that for m is equal to 3, what I'll be doing? I'll be placing a friend over here, here, and all of them will be gaining 3 times. All of them will be gaining the value chocolates 3 times. Just let me recheck the values whether size of the node minus depth is correct for everyone or not. Okay, one value was not added. That was the value of my root node. Size of the node 8. 8 will be a part of this. Okay, so I forgot one value that was of the root node. And now 9 values are there, 3, 3 and 9. Yes. Now all the values are placed and 8 will be the largest one. So 8 will be in the beginning. Sorting it in decreasing order. Okay, and here is our 8. So now we know that m value, like let's say I want to find the answer for m is equal to 3. So I know that on 3 of the nodes I will not be able to place any kind of chocolate, right? Because they will be occupied by my friends. So the smallest one whose value, the last, or the, let's say, m smallest values will be discarded, and you simply need to take the values of the m minus n minus m number of integers which are having the highest value. So if you take the n minus 1 integers who are having the highest value, then you will be getting the answer that this is the maximum number of chocolates your m friends will be gaining. What I am saying is that whatever is the value of m, discard m number of m smallest values. Discard m smallest value from the overall sum of this. So I'll be discarding this. And if I take this value, the sum of this 8 plus 3 plus 1 plus minus 1 minus 1 and minus 1. So this 3 will be cancelled out and 8 plus 1 will be equivalent to 9. So you can verify it from here as well. If you place all the friends, three friends over here, 9 8 8 at 9 8 and 7, you will be getting the maximum number of chocolates to be equivalent to 9. Okay, so let's say if m was equivalent to m was equivalent to, let's say, 4. If m was equivalent to 4, then orally, if you observe, I can place a friend here, here, and here, and we know we can place it over here. So that would be equivalent to 3 times 3, plus for this friend, he will be gaining chocolates only 1. So that would be 9 plus 1 will be equivalent to 10. And from this, I simply need to discard m smallest value, because on those nodes friends will be placed. So take the sum of this much of part, 8 plus 3, that would be equivalent to 11. 12, 12 minus 2, that would be equivalent to 10. And hence for m is equal to 4, the output comes out to be 10, which is exactly equivalent to what we found over here. So this is how we can solve this, and this is how we can reach the answer. This was not the this intuition part is not very easy to understand. I can uh, get you, but there are this many observations required. Was it clear? Can I get a confirmation from the audience so that we can quickly code this part, or I'll be sharing the code of it, because it's already, like, let's say, more than 2 hours. Okay. So this is how we go to find the answer. So let me just quickly write down the algorithm for the same. And first of all, I need to create an adjacency list. That is, build the graph. Because without building the graph, it will not be possible. Just let me quickly build the graph. Okay, so after building the graph, I know this contest, I'm taking much of time, but I want everyone to get a better understanding of every question. So this is the way I teach every question, that I go through each and every observation, each and every thought process which I am thinking while solving that question. Okay, if I'm solving this question in the let's say contest or everything, this is what I actually think. Okay, so first of all, I need to build the graph. Okay, so after building the graph, and if you want to find this value, no, this value, size of the node minus depth, you can use DFS function, right? Because if you already have the graph, then size of the node can be found by recursively doing DFS on each and every adjacent nodes, and depth can be passed in the argument, right? Because whenever you are making a function call from this, if you make a function call over here, pass depth plus 1. This is the basic algorithm to find depth, right? So this is how we will be getting the difference of size and depth for every node. Okay, a simple DFS. You simply need to iterate over entire graph at least once to get these values. Okay. So after building the graph, what I need to do, I will be doing a DFS and find the size of the node minus depth of depth for every node, and store it in a, let's say, any of the list or anything. Store it in a list. Now the next part is to sort in decreasing order. Decreasing order, sort this list that contains the difference of size and node, size and depth of the node. And now the answer is nothing but, what is the answer? Now you simply need to discard m smallest values that you need to iterate over the range 0 till n minus m, because this is how you discard m smallest values. So simply iterate over this range, I is equal to 0 till I is lesser than or equal to n minus m. Okay, let's confirm it's n minus m or what, because this is 0 based indexing. This is 0 1 2 3 4 5 6 7 8. Now for m is equal to 4, and what is this, n n is equal to 9. 9 minus 4 will be equivalent to 5. So how many nodes do you need to discard? You need to discard m number of nodes. So last m. So you need to iterate till n minus m, lesser than, not equal to n minus m. Because index 5 is over here. This is my index 5. And this is my n minus m. Yes, this is 9 minus 4 will be equivalent to 5. So iterate over 0 till lesser than n minus m, not equal to. And just take the sum value of it. I keep on adding it to your answer. List of 5. Sorry for bad handwriting, because I'm just trying to quickly note down the algorithm. And this is the entire algorithm. Now let's focus on what can be the time complexity. Building the graph is very easy, right? You simply need to iterate over the edges array. You are given edges in this manner, right? And the size of this edges array is equal to edges of I to 1. And the size of this edges array is equal to n minus 1. Okay, this is my size, and I'll be building the graph. I'll be creating an adjacency list, and now DFS. So it is mentioned that if there are n number of nodes, then there are n minus 1 number of edges, and this is the number of vertices. So DFS, a simple DFS on the entire algorithm. Over here, now here this is a tree. This is a tree. So on this tree, you will not find any kind of cycle. But as you have created a adjacency list, there is a possibility that you will be, let's say this is your current node. This is your current node. I'm explaining you how you will be handling the cycle part. You also need an array, right? That says whether this node is visited or not, because you are making a DFS call. And this is its parent from which the DFS call was made to this current. So in the DFS function, you can use one more argument that says this is my parent for this current node, because it will be in its adjacency list. This will be its neighbor 1 and neighbor 2. So just avoid calling again the parent function. So there won't be any requirement of using the visited array. Okay, so one extra argument in DFS function call, that is parent. So that would help me to uh, go in, like, let's say, infinite loop, a function call from parent to current of parent. This can be avoided in this manner. Okay, so I'll be passing that. So I don't need a visited array over here. Now obviously this is a tree, so there won't be any other kind of cycle, so this will be sufficient enough. Okay, just an argument parent to avoid recursive call. So what will be the time complexity of this DFS? Number of nodes plus number of edges, that is n plus n minus 1. And decreasing order, that would be how many numbers, how many nodes are there? N. So that would be n log n. And this is simple iteration, and this will be iterating n minus m number of times. So let's summarize the time complexity. Okay, so let's write down over here. Time complexity order of n minus 1. Let's take it as n, order of n plus, like, let's take this both of them as n, and let's take this as n log n, and let's take this as n minus m. So n minus. And talking about the space complexity, adjacency list was required. So that adjacency list will be taking size equivalent to order of n, that is nodes plus edges, n plus e. That would be n plus n minus 1, or you can write it down as n. And what about the DFS recursive function call? This DFS recursive function will be taking the size equivalent to the height of this tree. And let's assume this graph to be in this manner, that is similar to what a skewed binary tree is. So that would be order of n. Anything else? A list is required. A list will take order of n size, and nothing else. An answer array. This is nothing but a variable. So the space complexity is linear over here. I can write it down as order n. This is our time and space complexity for this graph question, the last one. Was this part clear? Can I get a quick confirmation? a quick confirmation, and for this I'll be showing you the code very quickly because it will take much time if I go into writing down the code for this same. Was it clear? Can I get a quick plus one in the chat box? Okay, thank you for the confirmation. And here is our code. Okay, so we have written the code exactly according to the algorithm which I have shown you right now. Okay, so this is the function. This function contains the argument number of nodes. This is the number of friends, and this is the edges array. So for first target is to create an adjacency list, or you can say generating a graph. So this is how you generate a graph in uh, Java. You need an array list of array list. This exact way in which you create vector of vector for adjacency list in C++. And you need to assign a new array, empty array list at each and every node. So this is what I have done. And now I'll be putting down the neighbors for every edge. That neighbor, the neighbor of 1 is 2 and the neighbor of 2 is 1, because this is an undirected graph. So this is creation of graph. Now I have created an array that is called size. This array will store the size of every node. Size of the node means the number of nodes in its subtree. Okay, and here is our list that will be sorted, and that would help us to gain the final answer. So I have called a DFS function, and in the DFS, this is simple DFS function in which the argument is current node. The numbering of nodes starts from 1 till n. This is parent in order to avoid visited array. This is the depth. Depth starts from 1. Parent of root is equal to -1. These are the initial arguments. Now, whenever I reach a node for the first time, then I'll be considering the size equivalent to be 1, initializing it, because that particular node will be in its subtree. Now, a DFS call to its neighbor will be made to all of its neighbor when I'll be increasing its depth, because neighbor will be at a higher depth, right? It will be deeper than your parent, and all of the neighbors will be returning their subtree's size. So I'll be keeping on adding that value for my current node in my size array at that particular node, and at the end inside the list I will be taking the difference of size of the subtree and its depth, and I'll be adding it in my list. And the return type of this DFS function is long, because I'm talking about the size. Why the return type of this function is wrong? Because what can be the maximum size of a node? Let me explain. So, as I mentioned, that this is a skewed tree, right? This is a skewed tree. So, for the first node, root node, the size will be equivalent to n minus 1. For this node, it would be equivalent to n minus 2. For this, it would be n minus 3, and this would be n minus 4, and so on and so forth. Right? So it is possible that each and every node returns some greater value. So I have taken it as a long for the safety purpose. And this is our DFS function. And after the DFS function is complete, I'll be sorting the list in reverse order. And at the end, I'll be taking an answer array. Just take first n minus m values. That is the largest n minus m values, and add it to your answer, and then simply return the answer. So in call y parent of 1, because 1 does not have any parent. No, I'm starting the DFS from 1 itself, and that is the root node according to the question. You can observe, uh, to complete the game, each of Geek's friend should move towards the root node, and this is a tree, and in this the root node is node number 1. For it, there won't be any parent. That is the reason. Okay, Arani Pawan, I hope you were able to understand this part. And let's try to compile and run, and let's see how are we getting any error or not. Okay, so compilation was completed, and now let's try to submit it. Again, obviously this is going to get accepted. So let me share this code in the chat box as well. array list of integer. Generally, we do for adjacency list, but look uh, your looks strange. Okay, no, that is not. This is not how you do adjacency list. No, adjacency list is a list of lists. No, this is a list of list. Here you can observe I have created this list over here. This is, sorry, this is the adjacency list. I guess you are saying about adjacency list. No, yes, adjacency list is a list of list. Okay, because we aren't sure that how many neighbors a particular node is going to have, and in order to store the uh, every neighbor, in order to store their numbers, I need an array list of arrays. So what? Let me show you the visualization. Let me share the other screen. So I have created, let's say this is a list, an array list. At each and every position, I have an entire array list. Okay, this is an adjacency list for the graph. And these are the indexes. This itself is an array list, and this is also an array list. This denotes who are the neighbors of node number 0. This denotes who are the neighbors of node number 1. Okay, I hope it was clear. So that was it for today's session. I guess I took a lot of your time, but I hope I was able to clear all of your doubt and you really enjoyed this session. Okay, so uh, that was it for today's session, and best of luck for the upcoming coding contest. And let's try to make the weekly coding contest count to 200, and we'll be uh, having an amazing session at that time. And also, if you enjoyed the session, do like and share with your friends. If they are looking for such a great content, then make them and you yourself subscribe to the Geeks practice channel as well. Okay, so hope to see you everyone in the next session. Thank you everyone. Thank you for joining. It was great interacting with everyone, and best of luck in your career as well and for the upcoming contest. Thank you, Pawan. If you really enjoyed the session, I appreciate. Okay, so we are ending the session here only. Thank you everyone, and good night. Bye bye.